हेलो स्टूडेंट्स, आई एम किशन कुमार। वेलकम टू माय यूट्यूब चैनल के मैथमेटिक्स। यहाँ पर मैं बीएससी स्टूडेंट्स के लिए सिलेबस बेस्ड वीडियोज अपलोड करता हूँ। अगर आप बीएससी कर रहे हैं या किसी भी कॉम्पिटिटिव एग्जाम की तैयारी कर रहे हैं और चाहते हैं विद इन सम मिनट्स आपका जो मैथ का कंसेप्ट हो जाए क्रिस्टल क्लियर, तो जुड़े रहिए मेरे यूट्यूब चैनल के मैथमेटिक्स के साथ। आज का जो टॉपिक है डिविजिबिलिटी। लेट a and b belongs to the set of integer z and b not equal to 0, then we say that b divides a if there exists an integer c belongs to z such that a equal to b into c। तो यहाँ पर अगर हम a को आज b का मल्टीपल लिख सकते हैं, तो यहाँ पर b जो है a को डिवाइड करेगा। सो हियर b इज द डिविजर ऑफ a, क्योंकि b जो है a को डिवाइड कर रहा है, एंड a इज द मल्टीपल ऑफ b, क्योंकि b मल्टीप्लाई बाय c इज a। फॉर एग्जाम्पल 2 डिवाइड्स 10, क्योंकि हम 10 को ऐसे लिख सकते हैं 2 into 5 where 5 belongs to z। एंड हियर 3 डिवाइड -81, क्योंकि -81 को हम इस तरह से लिख सकते हैं 3 into -27 where -27 belongs to z। Similarly x divide 0 for all x belongs to z, क्योंकि कोई भी इंटीजर x होगा तो हम इसे ऐसे लिख सकते हैं 0 equal to x into 0। So here every integer divides 0। नेक्स्ट जो है प्रॉपर्टीज ऑफ डिविजिबिलिटी इन थ्योरम नंबर 1, फॉर ऑल a, b and c belongs to z with a not equal to 0, then the following properties hold। इन फर्स्ट प्रॉपर्टी 1 divide a and a divide 0, क्योंकि a को हम ऐसे लिख सकते हैं a equal to 1 into a, तो ऑलवेज 1 डिवाइड a, तो कोई भी इंटीजर ले ले तो 1 सब इंटीजर को डिवाइड करेगा। एंड हमें पता है a जो है कोई भी इंटीजर ले ले तो इंटीजर जो है 0 को डिवाइड करता है। सो हियर a डिवाइड 0। एंड इन प्रॉपर्टी 2, इफ a डिवाइड b एंड b डिवाइड a, देन a इक्वल टू प्लस और माइनस b। तो यहाँ पर देखो, इफ a डिवाइड b देन वी कैन राइट b एज a into n where n belongs to z, and if b divide a, that means we can write a as a b into m where m belongs to z। From this that implies we can write a equal to b की जगह पर हम लिख सकते हैं a into m, तो this is equal to a into n into m, which is equal to a into m into n। That implies a equal to a into m into n। From this equation we get a into 1 minus m into n equal to 0, and here a not equal to 0, that implies 1 minus mn equal to 0, that implies mn equal to 1। that means either m and n equal to 1 or m and n equal to -1, क्योंकि -1 into -1 equal to 1 or 1 into 1 equal to 1। So here m can be 1 or -1, and from a equal to b into m we can write it as a equal to plus or minus b। Next जो है in third property, which is transitive property, if a divide b and b divide c, then a divides c। So here if a divide b, that means we can write b as a into m, and if b divides c, then we can write c as a b into n, and here m and n belongs to z, and from here c equal to b into n we can write it as c equal to b की जगह पर हम लिख सकते हैं a into m। So this is equal to a into m into n, which is equal to a into m into n, and here m into n also belongs to z, that's why a divides c। Similarly you can check in fourth property, if a divide b then a divide bx for all x belongs to z। And next in fifth property, if a equal to b plus c and a divides any two of the integer a, b and c, then a divides all the remaining one। तो यहाँ पर let a divide b and a divide c, that means we can write it as b equal to a into m and c equal to a into n, where m and n belongs to z, and here a equal to b plus c, which is equal to a into m plus a into n, which is equal to a into m plus a। So here a equal to a into m plus n, that's why a divides a by definition of divisibility। Similarly in case 2, let A divides A and A divides B. That's why that means we can write A equal to A into M and B equal to A into N. So here we can write C equal to A minus B, which is equal to A into M minus A into N, which is equal to A into M minus N. So here A also divides C. So here अगर A, B and C में से A अगर कोई भी दो इंटीजर को डिवाइड करेगा then other इंटीजर को भी डिवाइड करेगा. Similarly in sixth property, if A divide B and A divide C, then A divide the linear combination of B and C. That means for all x and y belongs to z, A divides bx plus cy. क्योंकि यहाँ पर देखो A अगर डिवाइड करेगा B को एंड A अगर डिवाइड करेगा C को, दैट मीन्स A डिवाइड करेगा bx को एंड ऑल्सो A डिवाइड करेगा cy को एंड हियर bx प्लस cy को भी ऑल्सो A डिवाइड करेगा. That's why A divide करेगा linear combination of B and C को. Similarly, you can check Ci belongs to Z. If A divides Ci, then A also divide the nth linear combination of Ci for all xi belongs to Z. Next जो है in theorem number 2, which is division algorithm, let A and B belongs to Z with B greater than u0, then there exists an unique integer q and r such that A equal to B into Q plus R, where R is greater than equal to 0 and less than B. And यहाँ पर A जो है ये है dividend and here B is the divisor, Q is the quotient and R is the remainder. And to prove this division algorithm, we have to prove it in two parts. One is existence of quotient Q and a remainder R, and another is uniqueness of Q and R. So in first we have to prove existence of Q and R. So in first case, if B divide A, that means we can write A as a B into Q for some Q belongs to Z. तो यहाँ पर हम R equal to 0 लिख सकते हैं. So here A equal to BQ plus R. And in case 2, if B not divide A, then consider a set A is equal to, इसके अंदर जो elements होंगे of the type A minus Bn, where An belongs to Z and A minus Bn greater than equal to 0. तो ये सेट को हम कंसीडर कर लेते हैं. नेक्स्ट वी हैव टू शो दैट दिस सेट इज नॉन एम्प्टी, क्योंकि यहाँ पर अगर a ग्रेटर देन इक्वल टू 0 होगा, देन फॉर n इक्वल टू 0, देन वी कैन राइट a इक्वल टू a माइनस b इंटू 0 व्हिच इज इक्वल टू a, एंड a यहाँ पर जो है ग्रेटर देन इक्वल टू 0, दैट्स व्हाई a बिलोंग्स टू s. एंड इफ a लेस देन 0, then choose n equal to a minus 1. So here a minus b into n equal to a minus b into a minus 1. So this is equal to a minus ba plus b, which is equal to a into 1 minus b in plus b. तो यहाँ पर देखो a जो है less than 0 and here b is greater than 0. That means 1 minus b is negative. That means 1 minus b less than 0. That's why a is less than 0 and 1 minus b is less than 0. That means इसका जो multiplication होगा which is greater than equal to 0. So here this is greater than equal to 0 plus b is greater than equal to 0. That means a into 1 minus b plus b greater than equal to 0. So here this is belongs to s. That means here s is non-empty. So here s not equal to 5. Then by OL ordering principle, s has a least element. Let assume कर लेते हैं s के अंदर जो least element है which is r, which is of the type a minus pq for some q belongs to z. Since R is belongs to this set S, then by definition of this set, R is greater than equal to 0. Then we have to show that R is less than B. Or let's assume if R is greater than equal to B, then here B is positive because B is greater than 0 and R is greater than equal to B. Then R minus B is greater than equal to 0. Also we can write R minus B equal to, R को हमने यहाँ पर assume किया था A minus BQ minus b, which is equal to a minus b into q plus 1. तो यहाँ पर q plus 1 जो है this is belongs to z, क्योंकि q belongs to z, that's why a minus b into q plus 1 belongs to this set S. That's why r minus b is belongs to this set S. So here b is greater than 0, that means r minus b less than r होगा, क्योंकि b यहाँ पर पॉजिटिव है, which is a contradiction, क्योंकि r जो है हमने assume किया था least element in this set S, and here R minus B is less than R and also belongs to S. That's why it's a contradiction. So here R cannot be greater than equal to B. So here R less than B. So we get R is greater than equal to 0 and less than B. And from R equal to A minus BQ, we can write it as A equal to B into Q plus R. Next check करते हैं uniqueness of Q and R. Let assume कर लेते हैं Q and R जो है unique नहीं है. There are two quotient Q1 and Q2 and two different remainder R1 and R2. So here we can write A equal to B into Q1 plus R1, where R1 less than B and greater than equal to 0, and A equal to B into Q2 plus R2, where R2 less than B and greater than equal to 0. And from these two equation, अगर हम ये दोनों equation को subtract कर ले, this is equal to A minus A equal to 0 and B into Q1 minus Q2 plus R1 minus R2 equal to 0, क्योंकि A minus A जो है this is equal to 0. So from this equation we get B into Q1 minus Q2 equal to minus R1 minus R2, which is equal to R2 minus R1. Here B into Q1 minus Q2 equal to R2 minus R1. That's why here B divides R2 minus R1. And यहाँ पर R1 and R2 जो है ये less than B है and greater than equal to 0 है. That means R1 and R2 जो है ये positive integer है and less than B. So that means ये दोनों का जो subtraction होगा R2 minus R1, ये जो है less than B होगा and greater than minus B होगा. And here less than B and greater than minus B के अंदर 0 के अलावा कोई भी इंटीजर नहीं है जिसको B डिवाइड करेगा. Since R2 minus R1 is less than B and greater than minus B, that means R2 minus R1 must be equal to 0. So here R2 equal to R1. And from this equation B into Q1 minus Q2 equal to R2 minus R1, तो यहाँ पर R2 minus R1 जो है 0 है, that's why B into Q1 minus Q2 equal to 0. And यहाँ पर B जो है greater than 0, that's why Q1 minus Q2 must be equal to 0. That's why Q1 equal to Q2. So here R1 equal to R2 and Q1 equal to Q2. Therefore, the integer Q and R are unique. Next है some important observations. Let A, B and N belongs to Z with N greater than 1. Then by division algorithm, if we can write A equal to Q1 into N plus R1 and B equal to Q2 into N plus R2. With R1 and R2 less than N and greater than equal to Z, then अगर ये दोनों इक्वेशन को हम सब्सट्रैक्ट करेंगे तो हमें मिलेगा A minus B equal to Q1 minus Q2 into N plus R1 minus R2. And in second observation, if A equal to Q1 into N plus R1 and B equal to Q2 into N plus R2, and here R1 equal to R2, that means here R1 minus R2 equal to 0. That's why A minus B equal to Q1 minus Q2 into N. That means here N divides A minus B. Then by definition of congruence modulus, if N divides A minus B, then A congruence to B mod N. Next in third observation, although A equal to B, that implies A congruence to B mod N. क्योंकि if A equal to B, then A minus B equal to 0. That's and N divides 0. That's why A congruence to B mod N. But converse not always be true. If A and B belongs to the set 0, 1, 2 up to n minus 1, इस set 0, 1, 2, 3 ऐसे ही up to n minus 1 के अंदर n सिर्फ 0 को डिवाइड करेगा. अगर A congruence to B mod n होगा, that means A minus B को डिवाइड करेगा n and A minus B must be equal to 0. That implies A equal to B. Next जो है floor function representation of divisibility. If A equal to B into Q plus R, where R is greater than equal to 0 and less than B, and B is greater than 0, then if divide B in this equation, we get A by B equal to Q plus R by B. And यहाँ पर R जो है less than B, that means तो यहाँ पर ये जो denominator है ये always greater than numerator होगा. That means ये R by B जो है ये greater than equal to 0 and less than 1 होगा. एंड ये R by B जो है 0 से 1 के अंदर होगा. दैट मीन्स ये R by B जो है ये डेसिमल वैल्यू देगा. सो हियर क्वोशेंट Q इज ए इंटीजर एंड दिस इंटीजर Q प्लस सम डेसिमल वैल्यू इक्वल टू A by B. सो हियर वी कैन राइट Q इक्वल टू 4 ऑफ A by B. एंड हियर R इक्वल टू A minus BQ. सिंपली क्यू की जगह पर फ्लोर ऑफ ए बाई बी पुट कर लेंगे, तो हियर आर इक्वल टू ए माइनस बी इंटू फ्लोर ऑफ ए बाई बी। किसी भी रियल नंबर का अगर हम फ्लोर फंक्शन निकालेंगे, दैट मीन्स फ्लोर ऑफ एक्स इज द ग्रेटेस्ट इंटीजर लेस देन और इक्वल टू एक्स। दैट मीन्स हियर फ्लोर ऑफ एक्स इज ग्रेटर देन एक्स माइनस 1 and less than equal to x. For example, find q and r if minus 31 divided by 30. So here a equal to minus 31 and b equal to 30. That means here q equal to floor of a by b. So this is equal to floor of minus 31 divided by 30. This is equal to floor of minus 4.6923. That means the greatest integer less than equal to this. So here the integer is minus 5. So here quotient equal to minus 5. And here remainder r equal to a minus b into floor of a by b. So this is equal to, here a is minus 31 minus b equal to 13 into minus 5. This is equal to minus 61 plus 65, which is equal to 4. So here quotient is minus 5 and the remainder is 4. Next, in theorem number 3, let a and b be the positive integers, then the number of positive integer less than equal to a and divisible by b is floor of a by b. तो यहाँ पर जो number of positive integers होगा which are less than equal to a and divisible by b, तो ये होगा floor of a by b. To prove this, let assume कर लेते हैं there are k number of positive integer which is less than equal to a and divisible by b. That means the positive multiples of b not exceeding a. That means a से छोटा जो positive integer होगा which is divisible by b, तो ये जो होगा ये multiples of b होगा। यहाँ पर b एक positive multiple होगा, 2b एक positive multiple होगा, 3b एक positive multiple होगा। ऐसे ही ये टोटल k नंबर ऑफ पॉजिटिव मल्टीपल्स रहेगा which is divisible by b and less than equal to a. तो यहाँ पर k into b जो है ये a को एक्सीड नहीं करेगा, that means k into b less than equal to a. This implies k less than equal to a by b. एंड यहाँ पर और एक अगर पॉजिटिव मल्टीपल ले ले b का तो ये एक्सीड कर जाएगा a को, that means यार k plus 1 into b जो होगा ये एक्सीड कर जाएगा a को, which is greater than a. From this, here k plus 1 is greater than a by b. That implies k is greater than a by b minus 1. So from these two equations, here k is greater than a by b minus 1 and less than equal to a by b. Therefore, k is the greatest integer less than or equal to a by b. So here k equal to floor of a by b. नेक्स्ट जो है इसके ऊपर बेस्ड कुछ प्रॉब्लम सॉल्व करते हैं। प्रॉब्लम नंबर 1, फाइंड द नंबर ऑफ पॉजिटिव इंटीजर्स लेस देन और इक्वल टू 3076 दैट आर डिविजिबल बाय 19। सो यहाँ पर a इक्वल टू 3076 एंड b इक्वल टू 90। तो यहाँ पर जो नंबर ऑफ पॉजिटिव इंटीजर्स होगा व्हिच आर लेस देन और इक्वल टू 3076 एंड डिविजिबल बाय 19. So by theorem number 3, this is equal to floor of a by b, which is equal to floor of 3076 divided by 90, which is equal to floor of 161.8947. So this is equal to greatest positive integer less than or equal to this. So floor of this equal to 161. So there are 161 positive integers which are less than or equal to 3076 and divisible by 19. Next, in problem number 2, find the number of positive integers less than or equal to 2776 that are divisible by 2 or 5. So here let there is a set A whose elements are positive integers which is less than or equal to 2776 and divisible by 2. Similarly, let there is a set B whose elements are positive integer which is less than or equal to 2776 and divisible by 5. Then to find the number of positive integer which is less than or equal to 2776 and divisible by 2 or 5, this is equal to cardinality of A union B. क्योंकि ए के अंदर जो एलिमेंट्स है डिविजिबल बाय 2 एंड बी के अंदर जो एलिमेंट्स है डिविजिबल बाय 5. And we know that the cardinality of A union B equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. यहाँ पर cardinality of A जो होगा ये this is a floor function of 2776 divided by 2 plus similarly cardinality of B जो होगा the number of element less than equal to 2776 which is divisible by 5. That means the cardinality of B जो होगा this is equal to floor function of 2776 divided by 5 minus तो यहाँ पर A intersection B का जो cardinality होगा the number of element less than equal to 2776 and divisible by both 2 and 5. That means the number of elements divisible by the LCM of 2 and 5. So here LCM of 2 and 5 equal to 10. So here cardinality of A intersection B equal to floor of 2776 divided by 10. So this is equal to floor of 1388 plus floor of 555.2 minus floor of 277.6. So this is equal to 1666. So there are 1666 positive integers which are less than or equal to 2776 and divisible by 2 or 5. Next जो है divisibility properties involving even and odd integers. As we know even integers जो होता है which is divisible by 2 and odd integer जो होता है which is not divisible by 2. Suppose in division algorithm b equal to 2. So here we can write a equal to 2 into q plus r where q is the quotient and r is the remainder. And here r is greater than equal to 0 and less than 2. So there are two possibility of r where r equal to 0 or r equal to 1. So if r equal to 0 then here a equal to 2 into q. That means here a is divisible by 2. So such integer is even integer. And if r equal to 1, then here a equal to 2 into q plus 1, such integer are called odd integer. Because here a is not divisible by 2. So from this definition, it follows that every integer is either even or odd but not both. Next, there are some basic properties of even and odd integers. The sum of any two even integers is even, and the sum of any two odd integers is even, and the sum of an even integer and odd integer is odd, and the product of two even integer is even, and the product of any two odd integer is odd, and the product of an even integer and an odd integer is even, and if the square of an integer is even then the integer is even, and if the square of an integer is odd then the integer is odd. Next, in problem 3, prove that the sum of any two integers of the form 4 into k plus 1 is even. Let arbitrarily choose two integers x and y of the form 4 into k plus 1. Let x equal to 4 into m plus 1 and y equal to 4 into n plus 1. So here in दोनों इंटीजर का जो सम होगा x plus y equal to 4m plus 1 plus 4 into n plus 1. So this is equal to 4m plus 4n plus 1 plus 1 जो होगा this is equal to 2. तो इसे हम ऐसे लिख सकते हैं 2 into 2m plus 2n plus 1. So here 2 into this equal to x plus y. So here 2 divides x plus y. That means here x plus y is the even integer. So here sum of any two integers of the form 4 into k plus 1 is even. Next, in problem number 4, prove that n square plus n is an even integer by cases where n is an arbitrary integer. So here since n is arbitrary, so there are two cases where n is even or n is odd. So in case 1, if n is even, that means we can write n as a 2 into m. So here n square plus n equal to 2 into m ka square plus 2 into m. So this is equal to 4m square plus 2 into m. So here we can write it as 2 into 2m square plus a. So here 2 into this term equal to n square plus n. So here n square plus n is a even integer. And in case 2, if n is odd, that means we can write n as a 2 into m plus 1. So here n square plus n equal to 2 into m plus 1 ka square plus 2 into m plus 1. So this is equal to 4m square plus 4m plus 1 plus 2m plus 1. So this is equal to 4m square plus 6m plus 2. So here we can write it as 2 into 2m square plus 3m plus 1. So here 2 into this equal to n square plus 1. So here n square plus 1 is even. So here for any arbitrary n, the n square plus n is even. आई होप ये जो डिविजिबिलिटी का कंसेप्ट है आपको समझ में आ गया होगा। अगर आपको वीडियो अच्छा लगा तो लाइक, शेयर एंड सब्सक्राइब करना मत भूलना।